Hello guys, hope all of you are doing great. In this part of the video, we are going to learn about variables in 8086 programming. Okay then, let's begin. First, let's see what is a variable. So, say for example, consider any high-level programming language, say C programming language. There you know like how you declare a variable. Say you want to store an integer number. You want to actually remember in your program, you want to remember an integer number. So for that reason, what you will do is you will declare an integer variable, and in that variable, you'll be storing that particular number that you want your program to remember, because you are going to use that number in your further computation. So for that reason, you want to remember that number in your program, and that's how you achieve your goal in C programming language, or more or less in any high-level programming language. Now the same thing if you want to do now in 8086 program, then how you're going to do it. To do that thing, or to do that thing, actually first you need to understand this thing. See, 8086 microprocessor, you can think of like, okay, it has this ALU, arithmetic and logic unit, that actually does all these executes all these instructions, and then these ALU is connected with a set of registers. Like already you might have used a few of them. Say for example, AX register, BX register, CX and DX registers, flag registers you have seen. And so a set of registers are there, the finite numbers of registers are there. And specific thing about these registers are like they are 16-bit in width. I mean, each registers are of 16-bit. But the point is, this ALU is connected with a set of finite numbers of 16-bit registers. Okay, now see here, along with these registers, this ALU is actually also connected with a big chunk of memory. Now see, these registers are certainly, they are memory unit. It means what? If you want your program to remember some data, then you can store those data in these registers. But see, since the number of registers are limited, it means what? Only if we have only these registers, then we'll be able to remember our programs. Will be able to remember only limited amount of data. Only few 16-bit registers are there. So certainly, only few 16-bit registers are not enough for all our computations. And another thing is that, just a side note, what happens is like there are some instructions when you execute those instructions, then they actually change the content of some of these registers. It means they actually use some of these registers as the storage to store the result of the the instruction. So that way also you cannot, your program might not be able to remember the value that you actually wanted it to remember, because some other, the execution of some other instruction might override the content of a register. So for that reason, what we need is actually, we need some, the first thing is that we need more memory, so that we can store more data there. And also we do not want these sort of default destination of instructions actually. So for that reason, what we have is, we have something called as data segment. Okay, this data segment is actually this big chunk of memory that is, you can think of like, is also connected with this ALU. This ALU actually can access memories. This data segment is nothing but it is a big chunk of memory. I said that thing. Now these memories, any part of this memory actually can be accessed by these ALU. Okay, up to that point, I guess things are making sense, right? Now the next point that I want to tell you is this variable thing, like how these variables can be declared. Now see, in terms of these registers, you can think of like each of these 16-bit memory units or memory chunks are given some specific name, like say AX, BX, CX, and DX, so that from your 8086 program, you actually can use these names along with some instruction. right? You do not have to actually tell like what is the where physically that memory is, what is the physical address. Just by writing the name of that that memory unit or that memory chunk, you can actually access that memory chunk. The same thing is true here also, and that thing can be achieved by declaring a variable. When I say declaring a variable, in the sense that what we want is, we want our program to reserve a certain amount of memory chunk, that is a memory chunk of certain width. When I say certain width, it means they could be of 8 bits, or some other memory chunks of maybe of 16 bits, or it could be of 32 bits or 64 bits. Okay, so that way different size chunks can be reserved by a 8086 program, and those chunks also can be given some name. Say for example, these 8 bits of memory chunk, I'm calling it, say for example, x1, and these 16 bits of memory chunk, I'm calling it, say, y1. These x1 and y1, these are called as actually variables. Now what are variables then? These are some dynamically created memory unit actually, uh, along with which some names are associated. And using those names, now we can like from our program, using those names, we can access those memory locations, and we can store our data there, or we can retrieve data from those memory locations. Okay, it means what? Now as soon as you have, suppose, obviously there are some instruction to achieve this thing. Actually achieve this thing means what? Reserve a certain length of memory chunk, and then give a name to that memory chunk. All these things can be done by using some instruction that I'll come in a moment. But before that, you see here, suppose we have achieved that thing. Okay, in that case, what you can do is you can write now move, say for example, x1 comma 5. It means if you want to store 5 in this memory location, then you can use the name of that particular variable, the name of that the name associated with those 8 bits of memory, you can use here in this way. So that is actually a variable. Now you see here the difference between variables and registers. Registers are already there. I mean, you do not have to create them. But these variables you create based on your need. When I say your need, means you as the programmer, based on the programmer's need. Because why do we write a program? To solve some particular problems, or to do some computation basically. And we different programs might need different types of data or different amounts of data for their computation. And so based on the programs that you are actually writing, you can, based on your need as a programmer, you can actually declare these variables in 8086 program, and then you can use these variables in different instructions. I hope you got more or less the idea. Now let's see how we can do it programmatically, actually, in 8086 program. Okay, then, so for that reason, we have to open this Visual Studio Code, and once you open it, then you go to Open Folder. There you have to select the C drive. Inside that, you will have this TASM 1.4. Inside that, this TASM folder is there. You have to open that folder, and inside that folder, we are actually writing all our ASM codes. So inside that folder, I'm going to create a new file just by clicking on this plus button, and I'm giving a name here. So for example, pp say 3.asm. Okay, and I'm creating this pp3.asm file. And here, let's first write the basic skeleton. And again, I could have copied it, but okay, let's write it. Just you also should try writing. I mean, when you write a program, it gives you no. It helps you actually understand the program. I guess in some way, it helps you understand the program in a better way. And see, programming is programming, no matter in what programming language you're doing it. You are doing it in C or C++, Java, or whatever the language it is. But at the end of the day, you will feel like you're doing programming means, you will not think much about the language actually. Okay, but how do you implement the logic, and those sort of things are more important. But anyhow, let's start. Dot model will be small, and data segment. I'm keeping it empty for the time being. I'll just fill it in a moment. And then we have this code segment. This also I'll fill it in a moment. And then this, we have this stack, and that starts with say 10h. Okay, and after that, let's do this code segment here. Let me first write the code to terminate the program. Say, for example, our program does nothing. It just starts and ends. Okay, so in that case, how do we know? How do we terminate a GH6 program? First thing is we have to move uh, 4ch 04ch to where? To AH register. And after that, we have to call the interrupt service routine by writing int 21h. So if, and then this is the end of the program. Okay. That's the basic skeleton, say, of the program. Now we'll be doing the specific tasks. What is the first thing that we want to do? We want to actually create these variables, right? And how do you do that? Now see, remember these things, I said, like, you have these big chunk of memory. This thing is actually called as, see here, I have also written data segment. This thing is called as the data segment. So whatever the variables you want to declare, that that part of the code you are going to write in data segment. Okay, so here, whatever the variables, no matter how many variables you want, if you want to use them, obviously first thing is that you have to declare them. And where you are going to declare it? You are going to declare it in the data segment, and that is the importance of the data segment. Now let's write it. Now we want, see here, we want 8 bits of memory, and we want to call that 8 bits, those 8 bits of memory collectively as x1. That's what we want to do. So how we're going to do it? First thing is you have to specify what is the name that you want to give to that chunk of memory. So you want to give it, you want to call it x1. That's done. Then the second thing you have to specify is what should be the width of that chunk. And there are like there could be 4 different widths, like say it could be of 8 bits and or 16 bits or 32 bits or 64 bits. Okay, and if you symbolically, how you're going to represent, okay, you want 8 bits, you have to write it like db. If you want 8 bits, you will be writing dw. If you want 16 bits, you will be writing uh, D maybe, okay, and then here it is DQ. These two we are not going to use much actually. So for this discussion, we'll be using these two only. Like, so if you want your variable to be of 8 bits, then you'll be writing the size here as dB. Okay, as dB. I want it to be of 8 bits, so I'll be writing here dB. And then if you want, you can store there a default value, like what by default you want to store in that particular in that chunk of memory. Now see here, if you do not write these 0 8s, then what will happen is it will allocate you. See, this allocation will be done anywhere within this data segment. Actually, it can happen like, it can allocate you the space anywhere in the data segment. So the by default, no matter how, whether they are 16 bits or 8 bits, by default these bits will have some values there, right, that you should comprehend. So if you want to override those values, then you can store actually there a some number, some known number, say for example 0h default value. Okay, done. Now, if you want, say another, say for example, you have created actually this particular instruction will allow, this particular line of code will actually create it will allocate 8 bits of memory in the data segment, and then those 8 bits will be given a name x1. That is, you have just declared a 8-bit variable in 8-bit variable whose name is x1. Okay, and then let's see, suppose we need like 16-bit variable, we need a 16-bit variable, and we want to call it say y1. So y1, and we need 16-bit its width, so we'll be writing dw, and then say default value is 0h again. So that way you can actually create the variables. Now I didn't say anything about. Now see, as soon as it is variables, you know, like, okay, what if we want to store say a string, or we want to store multiple numbers like arrays, how those concepts are like, you know, we can use those concepts in 8086 programming. So in those questions in this video I'm not answering. I'm just not showing you how to declare simple variables. Those arrays and strings, those programs are coming, you know, they will be coming in the next videos, or in the upcoming videos. Don't worry about it. Just initial state, like how you can declare variables, how you can use them with you know, with instructions, and in combination with registers and all these basic things we are going to see in debug mode, just to get the basic understanding. Okay. Okay, then we have created x1 and we stored 0 there, y1 we stored 0 there, and done. Now in our program, then what we want to do, what program we are going to write. So we'll write some code that will allow us to you know, to move some number from maybe register to, okay, let's do this thing. So what we will do is we will create a variable. The first step is that we will be creating a variable, a 8-bit or 16-bit, say for example 16-bit variable, and call it, say for example, x1. And then we'll be moving these say number to this x1, we'll be moving, say for example, 8. Okay, 8 and from this x1 now 8 and 8x. Okay, I can do it in this way also. Just a second, don't mind. You have this data segment. Here you have this x1, which is of 16-bit. Obviously this x1 is not the entire data segment. Okay, and then these, along with that, you have these registers here, right? These are the set of registers. Say for example, ax is there, bx is there, and then that way cx, dx, and all these registers are there. And this is certainly connected with this ALU. So this is sort of a very, you know, abstract view of the microprocessor. Then what we can do is, okay, now we programmatically first we will store the number 9 to x1. Okay, that is, we'll bring this number 9 to x1, and then this is your first step. And in the second step, what we'll be doing is we'll be copying this x1 to ax register, so this 9 will come here. And yeah, that if we do, and then what we can do is we'll be, say, copying 5 to this bx register, and from this bx register in the fourth step we'll be copying this 5 back to this x1 in the fourth step. That will make this 9 again back to 5. Okay, so these are things that we're going to do. What we're going to do is we are going to first obviously creating this variable x1, and then we'll be storing 9, the value number 9 we'll be storing in x1 in the first step. Then we'll copy that x1 value to ax register, and then we'll see, okay, what is the value of x. Once it is done, in the third step we'll store 5 now to bx register, and then from the bx register we will copy it back to x1. That's what we'll do, and we'll see it in debug mode. Okay, okay, then let's write the code. Say first thing is I want to declare a variable. I have already declared, but I have declared it in as db, but we in that program it is like, say, word, so I'm declaring it as word. Okay, x1 dw08, that's all. And then we will be moving 5 to x1. That was our first requirement, so we have to move 5 to x1. You can write 5 8s. I'm using these numbers within the range of 0 to 9 because I, for the time being at least, I do not want to get into the matter of like hexadecimal, decimal. But I will address that point very soon. x1 comma 5 8s, and then from this x1 we want to copy the value again to ax register. So move to ax register whatever it is the value of x1. Okay, and then we want to move now from register to x1, we want to do a copy. So for that reason, in register bx I'll be storing, say, the number 3. And from bx now we will be copying it to to x1. So in this instruction, we copied from register to variable, and then here we are copying from register to variable. No, no, sorry. Yeah, in this instruction, we copied from variable to register, and then here we are copying from register to variable. I guess you got the point. Now let's see how this program will be executed line by line, one instruction at a time. And you know how to do that? If we execute the program in debug mode, we can do that actually. Okay, then let's do it. To do that thing, again, you have to start. I'm sorry. This one. Exit. Okay. And this is the program. Now, this is pp3, so we have to first compile the program pp3.asm. I'm sorry, here I have to type tasm pp3.asm. So right now, no error, no warning, so we can proceed. So we'll be writing tlink pp3. Okay, that's also fine. Then we want to execute this program in debug mode, so we'll be writing td pp3. Done. Now let's see the execution of this program line by line. Okay, and see here, this is your program. Move x1, 5h. Okay, and here you see the corresponding program the corresponding instruction is written as like move word pointer 0004 comma 0005. See, okay, this 5 is okay, this 5h is as this is your 5h, no problem with that. But what is this? Now we have written here x1, but this x1 is replaced by this this thing actually, word pointer 0004. Okay, and in the next instruction you see move ax comma x1. Here also this x1 is replaced by 0004 within square bracket. Okay, and wherever there is this x1 in the fourth instruction, again there is this x1, so again it is replaced by within square bracket 0004. Now, what does this thing mean is here this x1, as I said, no, this x1 is nothing but it is, what is this x1? It is actually a name associated with a with a memory chunk of certain width, maybe 8 or 16 bits. Now, the at this number actually you can think of here, this number here, it is actually the address of that memory chunk. It is the byte number of that of that memory chunk. What I mean by that is, let's see here. Okay, right now the instruction which is going to be executed is this instruction. If you want to see, I wanted to show you actually what is this 0004. It means it is the 0004th byte in the data segment, actually. This is called as your data segment, right? This thing is there in your DS. Okay, and here in this DS there are like a lots of bytes are there, say byte number 0, byte number 1, byte number 2, like that. So let's see how, the way you can see the content of these registers, the same way you can see actually those bytes also, the content of those bytes also in data segment register. Okay, here is a mistake I did. Mistake in the sense that now I said DS register, but it is not actually DS register where all these bytes are there. It is actually these bytes are actually there in the data segment whose base address is stored there in DS register. So please, don't get it that way. Okay, DS register is only of 16 bits, whereas this data segment could be of 64 kilobytes. So these bytes are actually there in the data segment, and this DS register is data segment register in the sense that it contains the starting address of the data segment. So wherever I say DS register, please consider it as a slip of tongue in some way. I don't mean it like I don't mean actually when I say DS register, I actually meant the actual data segment. I'm sorry for that. Okay, so for that reason, what you have to do is you have to click on view. By default it is shown here, but then also you click on view and you click on this dump. This dump will show you the content of the data segment register. Now see, as I said, now these data segment registers, you can iterate over the content as a single bytes, like byte number 0. At right now at byte number 0, it has the content CD. This is byte number 1, byte number 2, byte number 3, 4, 5, 6, 7. This is byte number 7, and this is byte number 8. See here, this is this 8. This row is starting with 8. It means the first byte is the byte number 8. That is actually, you can think of the address of that particular byte. Now you might be thinking, okay, if it is a word, then what will be the address of that word? Yes, that's the thing. Like if it is a byte, then it's at 0008, this byte is there. If it is a word, then at 0008, this word is there. Okay, if it is a double word, then at 0008, these four, 8 bits are there. These 4 bytes are there. That way. Just think for a moment. This would make sense. Okay, then. Now let's come back to this debugging mode. Now this is our program. Let me show you the program here. This is our program. Now I'm going to execute this program in debug mode. Okay, so as soon as I press F, right now you see instruction pointer is 0000. It means this is the particular instruction which will be executed. Okay, now I'm going to press F7 at the count of 3, and then you should see some changes here. Okay, where these changes will happen. See here, word pointer 0004, 0005. It means we want to copy the content 0005 to the memory location 0004. And what type of memory location it is? It is a word pointer. It means they're like, starting from that memory location, we are talking about 16 bits. That is 2 consecutive bytes we are talking about. Because here, see, there are 4, there are 2 bytes there. Like this is the upper byte, 00 is the upper byte, and 05 is the lower byte, isn't it? Now let's first count up to 0004. Now see, in data segment, this is 0000, this is 0001, then this is 2, this is 3, and this is 4. 0, 1, 2, 3, 4. This is the 4th byte, and this is the 5th byte. See, this is 4th byte, this is the 5th byte. It means this is the higher order, these are the higher order 8 bits, and these are the lower order 8 bits. It means this is the H part of the register, and this is the sort of the L part of the register. So if we copy 0004, then see, this 04 is actually the content of the lower order 8 bits. So that way it will go to memory location. This no, sorry, we are copying 0005. The 005 is actually the content of the lower order 8 bits, right? So this 05 will go to memory location 0004. So it is 0, 1, 2, 3, 4. This 5 will come here, and this 00 is the content of the higher order 8 bits. So here, these higher order 8 bits will be replaced here. This EA will be replaced by 00. See here, 0, 1, 2, 3, 4. This 00 will become 05, and this EA will become 00 once I press F7 from my keyboard. Just think for a moment why it is so. We are copying 5 to the memory location 4, which is a word pointer. Memory location 4, which is a word pointer, it means 0, 1, 2, 3, 4. Word pointer means we're talking about these 2 consecutive 8 bits, 8 bytes. Sorry, these 2 consecutive bytes actually. Okay. Now this is the lower byte, and this is the higher byte. So 0005, 05 is the content of the lower byte, so it will go to this place, and 00 is the content of the higher byte, so it will go to this place. Okay, so I'm going to press F7 now at the count of 3. 1, 2, 3. See, 0, 1, 2, 3, 4. 4th byte is now 05, and then the next one is 00. So it means 05 is copied to this memory location in the data segment register. And after that, we want to copy. Now the rest of the things are quite straightforward. Move AX, 0004. It means from 0004. See, 0004 is a word pointer. So 0, 1, 2, 3, 4. That is, we want to copy these two consecutive bytes, and where we want to copy the content of these 2 bytes to AX register. Now AX is a 16-bit register, so we have these AL register, AH register. So from here, this is the lower part, I mean, lower least significant byte, and this is the most significant byte. You can think it like that: lower byte and upper byte, higher byte. So this 05 will go to AL register, 00 will go to AH register as soon as I press F7. Okay, I'm going to do it at 3. 1, 2, 3. See here, 05 and 00. Done. And then move BX comma 0003. Certainly it will make this 00 to 03. 1, 2, 3. Now it is making it 3. Then whatever it is the content of BX, we want to copy it to memory location 4. BX is 0003, so this 03 is the lower byte, and that will come here, and at fourth position, so 0, 1, 2, 3, 4. So this 5 will be replaced by 3, and then 00 will remain same. Okay, 1, 2, 3. 5 is 3, 00 is remaining same. And then 4C will be copied to AH, and 21H, it means termination of the program. Okay. Now that's how you can actually declare, variables in your 8086 program. Okay, guys, then that much only in this video. You guys, please now at least write this code by yourself, and see execute this program in debug mode, and check your understanding. Okay, and you just have to do it for say maximum 15 minutes, and once you do that, you will remember this thing actually for quite long period of time. Okay, guys, then have a nice day. See you in the next part.